let's begin talking about ticker tapes. So, constant positive velocity. Constant positive velocity means that the object is moving to the right with a constant positive velocity. So you can see that the little dots are evenly spaced. So what you need to do in that little space right there is draw the dots. You don't need to draw that many. Like even if you've got like 5 or 6, that's probably good. Draw this, and then we're going to draw the graphs as well. Okay. You'll notice that the position time graph, right, starts at 0 and it increases at a straight line. We can see that that is constant positive velocity because the position time graph is moving up in a straight line. Now if it's moving in a straight line, then that means that the velocity is not changing, and so it's flat. It's constant velocity, right? Velocity is flat. And if the velocity is flat, then that means that there is no acceleration, and so my acceleration is a graph right at 0. All right, so the next one, now some of you might remember what it looks like, but the next one says, I don't have a copy of it. Where are the rest of it?
I gave one to you.
Did you?
Yeah.
What did I do with it?
I did. Over here.
The next one is constant negative velocity. So what's it going to look like, Connor? Home. The next one. Constant negative velocity. What's it going to look like? The dots are going to be going?
To the left.
But are they going to be equally spaced?
Yeah.
Equally spaced. So, dots equally spaced, constant negative velocity. You'll notice that the position time graph is straight and angled down, right? Position time graphs that are straight mean constant velocity. The velocity time graph is a constant negative, so it's flat and in the negative region. And once again, the acceleration is 0 because the velocity time graph is flat. The next one, if you flip the page, the next one refers to positive velocity, positive acceleration. So that means moving to the right and accelerating to the right. So that means, in terms of constant speed, or what's the thing doing? Speeding up, which means the graph is going to be curved. The dots are going to be getting further apart, right? So positive velocity, positive acceleration, the dots get further apart. The position time graph is curved. The velocity time graph is now not flat, but it is still straight, but it starts at 0 because the speed is 0, and then the speed increases, the slope increases, so the value of the velocity increases. And now I do have an acceleration, and the acceleration is the slope of the velocity time graph. In this case, it's a positive value, and it looks like it's about positive 1.8. But the number doesn't matter. It just has to be flat and above 0. Positive velocity, positive acceleration. Alrighty, so that's positive velocity, positive acceleration. Now the next one, Logan, is positive velocity and negative acceleration. Positive velocity refers to going to the right, but negative acceleration means that it's accelerating backwards, so that means this object is
Slowing down.
slowing down, says Matthew. Would you agree with him?
Yeah.
Slowing down would be correct. Slowing down, the next one. The next one. If it's slowing down, what do the dots look like? Getting closer together, Logan. And if they're slowing down and the dots are getting close together, what does that mean for the position time graph? Is it, first of all, is it curved or is it straight?
It's curved.
It's curved.
It's curved like this. I was right.
Is that what you meant?
Yeah.
So it's slowing down, the dots are getting closer and closer together. It's moving positively, so it's above, but because it's slowing down, the slope has to get flatter, or smaller, has to get flatter. And if the slope gets smaller, then that means that the velocity is getting smaller, which means the velocity has to go down and approach 0, 0 of course being stopped. And if the velocity time graph is a straight line, then that means that the acceleration must be straight and flat. In this case, it's negative, because it's a negative slope, about negative 1.5. This was positive velocity, negative acceleration. The next one is?
Negative velocity, positive.
Now, actually, I think this is the one that I missed. I think I missed one when I did this little sheet, and I meant to fix it at my spare, and I didn't. My prep, and I didn't. So what you're going to have to do is, you're going to have to, on the back where it's blank, I would like you to write, because I know it's coming. I know it's coming. It's negative velocity, negative acceleration. Pretty sure. Let me double check. Negative velocity, negative acceleration. Write it on the back. Negative velocity, negative acceleration. So what does that mean? Negative velocity means moving to the left. Negative acceleration means accelerating to the left. So this guy's going to be speeding up to the left. How about you try and draw the picture and the three graphs? You got space. Don't use more than half the page, because I need to do a little bit more at the end. Okay? Just try and figure it out and see what you get. Here's what negative velocity, negative acceleration looks like. Of course, the dots are moving to the left. They're speeding up. So did you have them further apart? Yes. What about the graphs? How did you do?
Second one wrong.
The first one doesn't.
It starts at 0, and because it's moving left, it has to be negative. It increases speed, so the slope has to be more and more and more. The velocity starts at 0 because it's at rest, right? And it's going faster and faster and faster, but negatively faster, so it has to go down into that negative territory. And because it's accelerating at a constant rate, and because it's negative, it's flat, and it's in the negative region. What did you?
Left.
Negative velocity, positive acceleration. Negative velocity means moving to the left. Positive acceleration means accelerating to the right. So,
Slowing down.
slowing down. Slowing down. If the signs are opposite, if one's positive and one's negative, it's going to be slowing down. It doesn't matter which way it's going. Slowing down to the right. To the left, sorry. Negative velocity, positive acceleration. Slowing down to the left. Notice what the curved position time graph looks like. Right? It's going negatively, so it's down in a negative slope area, but it's flattening out because it's slowing down. And that means that the velocity is approaching 0. Approaching 0 means slowing down. And the acceleration, because this is a positive slope, acceleration is positive. The last one, don't start drawing it because it's a little bit different, okay? Don't start drawing it. In this case here, we have two cars, a blue one and a red one. Okay, don't start drawing it yet. Now, you can see here that the red car passes the blue car, which means that the red car is going to have to be traveling faster. Can you tell from the picture right here if they're traveling at a constant speed or not?
Yes.
It's kind of hard to tell because it's kind of stop motion, right? But you can certainly tell from the graph that they're traveling at a constant speed. How can you tell? Because they're straight. Okay, they're straight. Can you tell me at what time does the red car pass the blue car? 7 seconds, right there.
But it passes in at 7.
Tough to tell. It's not really a good animation, is it? From the graph, can you tell me at what position does the red car pass the blue car? At 60, right? This is not time here, by the way, right? This is the position. So it passes right there at 60 meters, right? Okay, so you can tell at what time it passes. You can also tell at what position it passes. Can you tell which one's going faster from the graph? Which one? The one that, the red one that's steeper. Okay. So what I want you to do is I want you to draw the graph just on the side. Okay? And then you're going to predict the velocity time graph that goes with it. Put it right beside it. Label yours guessed, and then I'll show you the real answer right away. So draw this and make a guess of velocity time. And I'm not going on until everyone makes a guess. Make ready. How many people have their graphs looking like this? This is the correct answer. Okay, let's just have a quick look at this here.
Yeah, I was right.
So, you might have, I saw quite a few people that had this kind of thing, but they started here.
Yeah.
Really, you don't see what's happening to the red one until after 4 seconds, right? Can you assume that it's traveling at the same speed before it appears back here? Yeah, likely. So if I had asked you that question on a test, I probably would have accepted that. But you need to, if you had something that looked kind of like this, you need to remember that velocity is the graph of the slope. The slope of this is a constant value, which means this is flat. The red one is a constant slope, so it's flat. Now, can you tell from just this picture I can pause it. Oh, that's not good. Can you tell from just this picture? I want it to keep going.
Click on
Oh, this one's behind.
No, I need the actual.
Oh.
Okay.
that.
You're half and half a cheerleader.
Hi, Trevor.
Hi, how are you?
I was good until this computer started. Okay, give me a second. See, they're opposite, aren't they?
No.
I'm going to stop talking right away. I'm going to give you the rest of the time. You got about 10 or 15 minutes, okay? If you got any questions about any assignments, the hand-in assignment. Please treat this as a review up to now. Don't ask me for a review for the test. I'm giving you the review early. Do it and hand it in. Do you see where it says up here, where it says hand in? That implies that I would want you to hand it in.
Really?
Wednesday, please. Wednesday. Wednesday. I understand it. I got a lot of stuff to do too. I am tentatively scheduling the test for Friday. I am tentatively scheduling the test for Friday. I just got it. I just got an email that said my Mark's Chandler. Marks are due Monday, so
Next Monday?
next Monday. So I have no choice. Friday. Friday.
Can I go through my stuff?